Learning for Beginners, Theory and Application, Part 4. This will be the applied portion of our computer vision section. So in the first part, we're going to detail some data preprocessing, and this will, of course, be in the context of image data, and it's going to involve, various transformations, such as flips, skews, rotations, pixel-wise shifts, some other operations that will increase the potential generalization accuracy of our models.
Okay, so what we're going to be doing in this first example is a little bit of data preprocessing or data transformation. And as I spoke on a little bit in the previous lesson and a bit more in this one, you're going to want to do data preprocessing on image data in particular when, it's a good habit to do it regardless, but when the perspective of your photographs can vary quite differently. So, for example, let's think of a human, right? Let's say, a good portion of your training examples for class human are, just someone facing straight forward, facing the camera, no angle or anything. And then at test or general, when you have deployed the model, you run into people who are laying down, are, looking off at an angle, etc., right? Your neural network has not learned those types of perspectives and the perspective-related features, right? So, for the most part, a convolutional neural network is going to learn low-level features and then correlate those to the higher-level class. These can be things like curves or edges or lower-level abstract shapes with not too much form, things like that, right? Eyes, those are a little bit in higher level, but convolutional neural networks can learn, eyes as well. So, it's important that if you're only learning one perspective, that your test time predictions are going to be only that perspective, because you can easily imagine the case in which you have a bunch of photos of the same perspective, and at test time you're going to have ones that are totally different, and it will end up with a low-performing, not accurate model as far as generalization goes. And that's what we're normally aiming for when we're really doing any project in machine learning, right? Because it's never the goal to be able to do well on your data set, right? You want to be able to generalize that with your model to new data samples that it hasn't seen, right? And that's what data preprocessing will do for us. It will allow us to perform affine transformations that will, in one way or another, allow the neural network to learn different perspective features. And that's going to be really helpful for us. Okay, so going in the code. For those of you who want to follow along with me, what I'm using is Keras. You could potentially use any framework here, be it TensorFlow, be it Keras, be it Torch. There's a couple of reasons why I'm using Keras. Most of the time when I'm just doing quick prototyping or, trying to solve a, let's say, trivial problem, many problems that neural networks can solve easily now, we consider trivial, even though they're really not trivial. But let's say just simple binary image classification, I would just throw Keras up, quickly run through and write up a simple model that can do the binary classification, and I won't have to worry about any of the lower level stuff in something like TensorFlow or Caffe, etc., any other framework. But of course, if you are doing something a bit more novel, in general, AI researchers will use something like TensorFlow when they're doing research, just because it helps to have access to some of the finer details of a network, be it, creating novel regularization or optimization or activation functions, or, just having more fine-grained control over training or what have you. But if someone is normally, just doing really simple problems, learning, or doing some fast prototyping, they'll more often than not opt for Keras. But more and more as the Keras API evolves, people are, using Keras more exclusively because, it has a good amount of features already as far as, accessing the finer layers of a neural network. For example, you can already add custom activations. You can already add custom regularizers. So, at some point it's really a matter of preference, but in general, you want to use TensorFlow when you're doing more complicated research level work, and Keras if you're just doing some quick prototyping. But anyways, aside from that, I have Keras running on top of TensorFlow. You can also use Theano, which isn't really supported much anymore, but I believe even the latest version of Keras will still run on Theano without any problems. And then I'm also running on Mac OS X, which isn't too important for this, but Linux and Windows should be essentially the same thing, from Keras to TensorFlow to even PyCharm for the most part. Okay, so then quickly I will just run through this code below. What we're doing here is, up here we're establishing our image data generator, and then we're loading our image, which is just this cute image of a cat. At least I think it's cute. And then we're converting it to an array of pixels, right? So right here, our shape will be, and I printed it out already before I ran this previously, but our shape here will be 410 by 410 by 3. And you may notice, that is different than the convention that I stated in the previous lecture. And yes, that is. TensorFlow has different dimensionality or channel ordering. It is, something very important to keep in mind when you're going through any sort of problem. Is my dimensionality ordering correct? For the most part, that won't be too much of an issue in tabular data, but as you go into image data and NLP, which will normally utilize LSTMs and time-based features, you're going to want to pay closer attention to your dimensionality. Right. So then we are just printing the shape, as you see down below. From there, we are expanding the dimensionality, and you might ask, why are we reshaping this? It's because we have a batch size of 1, right? So whenever you are doing machine learning via Keras or most any other machine learning framework, you're going to indicate batch size as another dimension, because for the most part, you're not doing something like online learning or what have you, where you're doing one sample at a time. You're normally going to do mini batches, which is taking a subsample of your data of, let's say, size 16, 32, all the way up to 510, and summing and averaging your gradient updates through all those samples. And what this will do, besides evening out extremely erratic gradient jumps and reduce divergence, it will also reduce computational complexity quite a bit, obviously, because we're going over a batch of images and not going one by one. Online learning, on the other hand, which is one sample at a time, it can have some benefits in certain situations as well. More often than not, that will be in reinforcement learning. But in some image problems and tabular data problems, it can be useful to at least try as well. The other benefit of online learning is that it is 100% data efficient, right? Because we're not averaging over this sum of all our gradient updates for each image for the batch, we're actually, using each image and all the data to its full efficacy, right? And then down here, it's pretty simple. We're instantiating I, which is going to tell our for loop when to break, and then we have this datagen.flow method. And all this does is allow you to perform, n transformations on your data and save them, or create another data set. It's a very useful function that is included in Kairos, and I'm really appreciative that's there because it makes something like this much easier to do.